Assalamualaikum, my name is Nur Amin binti Mukti. Today I will talk about basic principle of ultrasonic testing. General inspection principle of ultrasonic testing. A typical ultrasonic testing inspection system consists of several functional units such as the pulsar or receiver, transducer, and display devices. A pulsar or receiver is an electronic device that can produce high voltage electrical pulses. Driven by the pulsar, the transducer generates high frequency ultrasonic energy. Then it continues when the sound energy is introduced and propagates through the material in the form of wave. When there is a discontinuity, such as crack in the wave path, or part of the energy will be reflected back from the floor surface. The reflected wave signal is then transformed into an electrical signal by the transducer and is displayed on a screen. Then, signal travel time can be directly related to the distance that the signal travels. From the signal, information about the reflector location, size and orientation, and other features can sometimes be gained. In the next page, the reflected signal strength is displayed versus the time from signal generation to when an echo was received.
A transducer converts an electronic signal into ultrasonic sound waves. It can both send and receive.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafawati binti Adumana, and today I will be presenting about test technique in ultrasonic testing. These are the three primary classifications of the ultrasonic testing technique. In pulse echo testing, the transducer performs both the sending and the receiving of the pulse wave as the sound is reflected back to the device. In true transmission testing, a transmitter sends ultrasound through one surface and a separate receiver detects the amount that has reached on another surface after traveling to the medium. In contact testing, contact transducers are used for direct contact inspection and generally hand manipulated. Coupling materials of water, grease, oil are used to remove the air gap between the transducer and the component being inspected. In immersion testing, the component or material is submerged in a water which acts as a coupling in place of the gel used for contact ultrasound. In normal beam testing, the sound beam is introduced into the test article at 90 degrees to the surface. The normal beam testing also commonly employed in testing fiberglass and composite. In angle beam testing, the sound beam is introduced into the test article at some angle under the 90 degrees. In typical inspection, the sound beam will travel to the designated angle down to the bottom of the test piece and then reflected upward at the same angle. These are some of the inspection applications. First, fall detection, erosion and corrosion thickness gauging, assessment of bond integrity in adhesive joint and waste component, estimation of void content in composite and plastic, measurement of case hardening depth in steel, and estimation of grain size in metal. Flaw detection is the most commonly used technique among all the applications of industrial ultrasonic testing. Generally, sound waves of high frequency are reflected from flaws and generate clear echo patterns. Portable instruments record and display these echo patterns. Ultrasonic thickness gauges are designed to measure thickness of the material from one side using ultrasonic wave. When an ultrasonic wave is sent to the material, this signal is reflected by the back of the wall of the material and received by the wall thickness gauge. The common application of ultrasonic thickness gauge are used for measuring corrosion on sheet holes or inside pipe from the outside. That's all from me. Thank you.
My name is Lena Zara binti Rosli. My metric number is 143555. Today I'm going to talk about the equipment. So there are three basic components that comprise an ultrasonic test system, which is transducer, instrumentation, and calibration standard. Transducer is a manufactured variety of form, shape, and size for verifying application. So these transducers are categorized in a number of ways, which include contact or emission, single or dual element, and normal or angle beam. Contact transducers are designed to withstand rigorous use and usually have a wet plates on the button surface to protect the piezoelectric element from contact with the surface of the test articles. Image transducers are designed to transmit sound where the transducer and the test specimen are immersed in a liquid coupling medium. So basically they are manufactured with planar, cylindrical or spherical acoustic lenses. Two elements of transducer, where the contact transducer are available with the two piezoelectric crystal in one housing. The one crystal it acts as a transmitter, the other is a receiver. So it will improve the near surface resolution because the second transducer does not need to complete a transmit function before listening for echoes. Single element of transducer is to improve the near surface resolution with a single element transducer through the use of delay lines. Delay lines have a plastic piece that is a sound pulse that provides a time delay between the sound generation and reception of reflected energy. Normal or angle beam of transducer, with the incident wedges angle used with the material velocity to determine the desired refractation wave according to Snell's law. Transducer can use fixed or variable wedges angle. The second basic component is instrumentation. So there are four general categories for instrumentation, which are the dimeters, flaw detector, industrial and special application. Dimeters or digital thickness gauge instruments provide the user with a digital readout. They are designed primarily for correction or erosion inspection application. So the advantage that they allow the user to evaluate the signal to ensure that the digital measurement are of the desired feathers. Flaw detectors are designed primarily for the inspection of components for defects. However, the signal can be evaluated to obtain other information such as material thickness value. Should also offer the user getting horizontal sway and applicate threshold. Industrial flaw detection instrument provide user with more options than standard flaw detection, which are modularly unique, allow user to tailor the instrument for their specific need. Special application. Immersion ultrasonic scanning systems are used for automated data acquisition and imaging. They integrate an immersion tank, ultrasonic instrumentation, a scanning bridge, and a computer control. The last basic component is calibration standard. Calibration is an operation of figuring the ultrasonic test equipment to know the value. This provides the inspector with a meaning of comparing test signal to the known measurement. Type of standard. Thickness. Calibration standard may be flat or curved for pipe and tubing application, consists of simple variation in material thickness. Distant area amplitude standard utilize the flat bottom holes or upside three holes to establish no reflector size with change in sound pulse from the entry surface. Angle beam. This standard utilize side three holes, notch, and the geometric configuration to establish time, distance, and amplitude relationship. Qualification standard is used for the purpose of verifying proper equipment operation and qualification of equipment used for specific goals and standard.
Assalamualaikum, my name is Nur Sabrina Safia. Today I would like to present about the data presentation, disadvantages and advantages of ultrasonic testing. For the data presentation, ultrasonic data can be collected and displayed in a number of different formats. There are three most common formats in this non-destructive testing, which is A scan, B scan, and C scan. Modern computerized ultrasonic scanning system can display data in all three presentation forms. Each presentation mode provides a different way of looking at and evaluating the region of material being inspected. So from this slide, we can see that A scan, B scan, and C scan are located at different locations of observed data presentation. For A scan presentation, the S scan presentation displays the amount of received ultrasonic energy as a function of time. The relative amount of received energy is plotted along the vertical axis, and the elapsed time, which may be related to the sound energy travel time within the material, is displayed along the horizontal axis. By comparing the signal amplitude acquired from an unknown reflector to that known reflector, the relative discontinuity size can be determined. Reflector depth can be determined by the position of the signal on the horizontal strip. Scan presentation. B-scan refers to the image produced when the data collected from an ultrasonic inspection is plotted on a cross-sectional view of the component. From the graph, the time of flight travel time of the sound energy is displayed along the vertical axis, and the linear position of the transducer displayed along the horizontal axis. For the reflectors near the surface may be covered by larger reflector, which is a limitation of this display technique. For the C-scan is a data presentation method applied to past echo and transmission technique. It yields a two-dimensional plan view of the object. The CT scan presentation provides a plan-type view of the location and size of test specimen features. The plane of the image is parallel to the scan pattern of the transducer. Advantages of ultrasonic testing. First, in terms of speed, advanced ultrasonic technique like phase array and time of flight diffraction can provide immediate result. As soon as the probe passes over the surface of the material, the instrument software displays a visual image of this interior. Second, in terms of ease of use, while ultrasonic testing does require training and certification, modern software and instruments render the process smooth and intuitive. In addition, scans provide little vibration and lightweight, cordless instruments are easy to carry. In terms of depth, ultrasonic scan thin and thick materials at the same effective rate. They travel more deeply through material than other analytic methods, enabling greater flaw detection. Lastly, disadvantages of ultrasonic testing. First, training is more extensive than other methods. Second, more expensive than other methods. Third, difficult to use on thin material. Fourth, geometry part can cause complication. Fifth, need relatively smooth surface to couple transducer. It must know velocity of part and have reference to calibrate again for equipment setup. That's all from me. Thank you.